Hello everyone. Today I'm here with you all with the topic algebraic expressions for class 8. In this video we will be learning what algebraic expressions are, what all are the types of algebraic expression and how to add, subtract, multiply or divide the given algebraic expressions. So let's start with the topic, that is your algebraic expressions. So first of all, what constant is? Constants are the symbols which is having the fixed value. So whenever we are using the numbers like your 2, like your 5, or we can say 3 upon 7, whensoever we are using these type of numbers, in whatsoever the context we will be using it, their value will remain same. So the symbols whose value remains the same, wheresoever we are using it, such type of symbols are known as your constant. Then comes your variable. Variables are the symbol whose value varies. That means if we are using these symbols are denoted by your alphabets like your X, Y, Z, it could be A, it could be B. These are the representations of your variables. If I am going to use this X in some context, its value could be 2, its value could be 3. If I am going to use the same variable X in some other context, its value could be 7 even, it could be -5 even. So whenever we are using these variables, their value varies. It is not constant, it does not remain same. It will be varying. So such type of symbols whose value varies are known as your variables. Variables are even known as your literals. Then comes your combination of constants and variables. When we are combining the constants and variables with your plus sign, minus sign or multiplication or the division sign, the result is even a variable. Like if I am going to say 3 plus x, over here 3 is a constant and x is a variable. We have combined them with your plus sign. So the value of 3 plus x will be a variable only, because x could be your 2, x could be 3, x could be -5. So the value of 3 plus x is depending upon x, which is varying. That's the reason resultant 3 plus x will even vary. So whenever we are combining a constant and a variable, either your plus sign or your multiplication sign or your subtraction sign, whatsoever the sign we are using, if we are combining a constant and a variable, the result is even a variable only. It will even depend upon the variable. That's the reason result will be a variable. It will vary according to the value of the variable. Then what term is? Term could be a constant, term could be a variable, and term could be the combination of a constant and variable. Like if I'm going to say 5 is a term, your x is even a term, and if I'm going to combine them, 5x, it is even a term. The combination of your constant and variable should be either your by multiplication sign or the division sign. That means if constants and variables are combined, either they should be multiplied or they should be divided, then whatsoever we are getting will be a term. Like 5 is a constant, we have said, this is your variable. We have combined them using multiplication sign, so it has become 5x. So 5x is even a term. Similarly, if we are going to divide it, so 5 upon x is even a term. So whenever we are combining the constants and variables with either multiplication sign or division sign, we are getting the terms. Similarly, we can say your 3xy is even a term, because 3 is multiplied by x is multiplied by y. So whenever we are multiplying or dividing the constants and the variables, then it becomes your term. Individually, your constant is even a term. Individually, your variables are even a term. Now, what algebraic expressions are? When a single term is there or combination of two or more than two terms we are taking, and we are connecting these terms either with your plus sign or minus sign, then we are getting the algebraic expression. Like if single term I am talking about, so your 5 is even a algebraic expression. Your xy is even a algebraic expression because it is a term. Xy is even a term, 5 is even a term. So individually we can take a single term also, it is even an algebraic expression. And when we are combining two or more than two terms with your plus sign or your minus sign, it becomes your algebraic expression. So like if I am saying 5 plus xy is even an algebraic expression, we can say your 3xy minus 7y plus 17. it is even an algebraic expression. So whenever we are combining or connecting your terms using your plus sign or minus sign, we are getting algebraic expressions. Now let's see how many types of algebraic expressions are there on the basis of terms. It is your monomial, binomial, trinomial, or we can say multinomial even. If the number of terms is 1 in the algebraic expression, if the number of term is only 1, then we say it to be a monomial. Like individually, if I am saying this, 5 is an algebraic expression which is having only one term. It is an monomial. If I am going to take this xy, it is even an algebraic expression, and in this algebraic expression there is only one term, that is your xy, so it is even a monomial. We can say your 7xyz is even a monomial because there is only one term, that is your 7xyz. So if in the algebraic expression there is only one term, then such type of algebraic expressions are known as your monomial. If number of terms is 2 in the algebraic expression, then it is your binomial. Like your this 5 plus xy. We can take this as an example, 5 plus xy. In this algebraic expression, there are two terms. One is your 5, another is your xy. These two are the terms. So this type of algebraic expressions are known as your binomial. We can say 7xy plus 5y. It is even a binomial because there are two terms. One is your 7xy and second term is your 5y. So these type of algebraic expression in which there are two terms, exactly different two terms, such type of algebraic expressions are known as your binomial. If the number of algebraic in the algebraic expression number of terms is exactly 3, then such type of algebraic expressions are known as your trinomial. Like if I am going to take this as an example, it is your 3xy minus 7y plus 17. In this algebraic expression, there are three terms are there. One is your 3xy, another is your minus 7y, and third term is your 17. So when there are three terms in any of the algebraic expression, we say it to be a trinomial. Or we can say 5 plus 3y plus 7x. This is even an example of your trinomial because in this algebraic expression even there are three terms. One term is your 5, another term is your 3y, and the third term is your 7x. So whensoever there are three terms in any of the algebraic expression, we say it to be a trinomial. Now what multinomials are? Multinomials are the algebraic expression which are having either 2 or more than two terms. The algebraic expression which is having either 2 or more than 2 terms, such type of algebraic expressions are known as your multinomial. That means binomials are even multinomials, trinomials are even multinomials, and if there is an algebraic expression which is having 4 terms or 5 terms, all these algebraic expression will come under the category of your multinomial. Hope it is clear to you what variables are, what constants are, what your term algebraic expressions are, and what all are the types of your algebraic expressions. Now let's see what is polynomials. Polynomials are the special type of algebraic expression whose every term could be denoted as your ax raised to the power n, where a is a constant, x is a variable, and n is any of the whole number. That means if every term of the algebraic expression is having the power of the variable as your whole number only, then such type of algebraic expressions are known as your polynomials. Like if I am going to take an example, 2x raised to the power 5 plus 5x raised to the power 3. If we are going to take this algebraic expression, so in this algebraic expression there are two terms are there. This is one of the term, this is another term. In this term, the power of x is your 5, which is a whole number. In this case, the power or the exponent of x is your 3, which is even a whole number. So whensoever we are having the power or the exponent of the variable as your whole numbers, then such type of algebraic expressions are known as your polynomials. Like if I am going to say 2x raised to the power minus 5. In this case, the power of x is your minus 5, which is not a whole number because the power is your negative. So it is an example of algebraic expression, but it is not an example of polynomial. Similarly, if I am going to say y raised to the power 3 by 2. In this case, the power of the variable is your in fraction, that is 3 by 2. So it is even not a whole number. That's the reason it is not a polynomial, although it is an example of your algebraic expression. So whensoever the power or the exponent of the variable in each and every term of the algebraic expression is a whole number, then we say such type of algebraic expressions as your polynomials. Now what degree is? Highest power of the variable in any of the polynomial or the algebraic expression is known as its degree. Like if I'm going to take this example. In this example, this term, this is one of the term and this is one of the term. In this term, the power of the variable is your 5, and in this term, the power or the exponent of the variable is your 3. So which is higher in this case? 5 is higher. That's the reason degree of this polynomial or this algebraic expression will be 3. Individually for each and every term, we will be finding the highest power of the variable, and then we will be checking it, which variable, which term is having the highest power of the variable. Such number, that number will give you the degree of the polynomial. Like if I am going to say 7x raised to the power 15 plus y raised to the power say 5 plus your xy raised only we are taking your z over here, we are taking another variable, that is z raised to the power 7. So in this term, the power of your variable is your 15. In this term, power of the variable is your 5. In this term, power of the variable is 7. So which is higher in this case? 15 is the highest value. So that's the reason the degree of this polynomial or this algebraic expression will be your 15. The highest power of the variable will give us the degree of the algebraic expression, or we can say polynomial. Now if I am going to say, suppose your terms are like 7xy, x raised to the power 2, y raised to the power 3 plus 5, x raised to the power 5, y raised to the power 3, then your plus say 2, x raised to the power 3, y raised to the power 4. If this is a algebraic expression, in that case, how to find the degree of this algebraic expression? So what we will be doing is, we will be adding the powers of all the variables for each term. For this term, we are considering first. Here, power of x is 2 and y is your 3. So 2 plus 3, it means 5 is the degree for this term. Now coming to this term, here power of x is 5 and power of y is 3. So 5 plus 3 is 8. Here in this term, power of x is 3 and power of y is 4. So 3 plus 4, it is 7. So highest power of the variables is your 8. That's the reason the degree of this algebraic expression will be 8. Now, according to the degree of the algebraic expression or the polynomial, we can categorize the polynomials into these categories. One is your linear polynomial. So what are the linear polynomials? If the degree of the polynomial is your 1. If degree is 1, then we say such type of polynomials as your linear polynomial. Like we can take an example. If I am saying 5x, over here the power of x is your 1. That means its degree is 1. And if degree is 1, such type of polynomials are known as your linear polynomials. If I am talking about quadratic, so if the degree of the polynomial is 2, then such type of polynomials are known as your quadratic polynomials. Like we can take an example, 7y square. 7y square is having your power of y is your 2, or we can say 7y square plus 5y plus 2. If this is even a polynomial, in this case also its degree is your 2, because for this term highest power of variable is 2. For this term, highest power of variable is 1. For this term, there is no variable part. So highest power for all the three terms is your 2 only. That's the reason this is an example of your quadratic polynomial. If the degree of the polynomial is 3, then such type of polynomials are known as your cubic polynomial. Like if we are going to take an example, 2x raised to the power 3 plus 5x raised to the power say x only, or minus of 5. If this is a polynomial, in that case we can see over here that the highest power of the variable is 3. That's the reason the degree of this polynomial is 3, and this is an example of cubic polynomial. What is a constant polynomial? Constant polynomials are in which there are constants only. There is no variable part is there. Like if I am going to say 5 is a constant polynomial. If I am going to say 7, it is a constant polynomial. And for constant polynomial, degree is your 0. Why degree is 0? Because 5 could even be written as 5x raised to the power 0. We know if there is any base with the power 0, its value is 1. So x raised to the power 0 will be your 1. So this could even be written as your 5. And power of variable over here is your 0. That's the reason degree for constant polynomials is your 0. Now what product is? We know what product is. Whenever we are multiplying 2 or more than 2 constants, variables or both, then whatsoever the result we are getting is your product. Like if I am saying 2 multiplied by your x, then 2x is the product. Here we are multiplying a constant and a variable. If I am going to take minus 5 into y into z, then minus 5yz is the product. Similarly, whenever we are multiplying 2 or more than 2 constant could be there, variables could be there or both could be there, then we are getting the multiplication of these two, that is known as your product. What factors are? Factors are each of the quantity, that could be a constant, that could be variable, or it could be both even, which forms the product. Like in this case, this is the product and factors for this will be 2 is a factor, x is a factor. These are the factors of this product. If I am going to take this an example, this is a product, minus 5, yz is a product, whose factors will be minus 5 will be the factor, y will be the factor, and z will be the factor. So these will be the factors of this product. So what factor is? Each of the quantity, it could be constant, it could be variable, or it could be both even, which is forming the product is known as factor of the product. So it could be the factors for this. Factors for this term could be minus 5, it could be y, it could be z. It could be your minus 5y also. It could be your yz also, because these are even forming your product. So all these are the factors of your term, that is your minus 5yz. Now what is numeral factor? If in the factors there are only constants are there, then it is a numeral factor. For 2x, 2 is the numeral factor because it is having only constant factor. In this term for the 2x, we have said that 2 is one of the factor and x is one of the factor, but 2 is a constant factor because it is having your constant value only. So such type of factors are known as your numeral factor, which is having only constant factor. Such type of factors are known as your numeral factor. Literal factors are the factors which is factor containing only literals, like y, it is having only literal, z, it is having only literal. So these factors, these type of factors are known as your literal factors. Factors which is having only literals, only variables which is having, are known as your literal factors. So this is literal factor for your minus 5yz, z is even a literal factor, x will be a literal factor for your 2x. The factors which is having only your literal parts they are having, such type of factors are known as your literal factors. Now what coefficient is? Any factor of algebraic quantity is called coefficient of remaining quantity. Like if I am going to say 2xyz, so what will be the coefficient of z? So remove z, what else is remaining will be the coefficient of z. That means 2xy will be the coefficient of z. Now for this only, if I am going to say what will be the coefficient of yz, then 2x will be the coefficient of your yz. Just remove yz from it. What is remaining? 2x is remaining. So 2x will be the coefficient of your yz. Coefficient of 2 will be, it will be your x, y, z will be the coefficient of 2. Just remove 2. What is remaining? X, y, z is remaining. So x, y, z will be the coefficient of your 2. So whenever we are taking any factor of algebraic quantity, all these are the factors. 2xy is a factor, 2x is a factor of 2xyz, xyz is a factor of 2xyz. So any factor of algebraic quantity is called coefficient of remaining quantity. Now if I am going to say what will be the coefficient of 2x, in that case yz will be the coefficient of your 2x. So this is how we can find the coefficient. You must have understood what polynomial is, how to find the degree of a polynomial. According to the degree, how many types of your polynomials are there, what is product factor, what is numeral factor, what is literal factor, and what coefficient is. Now let's understand what are like terms and what are unlike terms. Like terms are the terms which is having the same literal coefficients. If there are two or more than two terms which is having same literal coefficients, then we say such type of terms to be your like terms. Like if I'm going to take an example, 2xy, 5xy, minus 7xy. In these terms, your literal coefficient is your xy only. Xy is a literal coefficient for all the three terms. So such type of terms which is having the same literal coefficients are known as your like terms. Now what unlike terms are? Terms which is having your different literal coefficients are known as your unlike terms. Like if I am going to take an example, 2xy, 2x square y, 3xy square, all these are your unlike terms. In this, the literal coefficient is your xy. In this, literal coefficient is x square y. In this, literal coefficient is your xy square. So in all the three terms, your literal coefficient is your different. That's the reason these are your unlike terms. Whenever we are adding or subtracting any algebraic expression, it is always done only on the like terms. We cannot operate, we cannot combine your unlike terms. For combining your terms, we need to, it is compulsory that the terms should be your like terms only. Like take an example, suppose we have to add this algebraic expression and this algebraic expression. We need to add these two algebraic expression. So what we will be doing is, we can make the columns of it even. First of all, we will be writing one of the algebraic expression. This is one of the algebraic expression. I am writing it over here. 2p square q square minus 3pq plus 4. This is one of the algebraic expression we have written. Now we have to add this algebraic expression with this algebraic expression. So whatsoever the like terms are there, we will be keeping one over the other. Now p square q square is the literal coefficient for this term, and in this algebraic expression, this term is having the same literal coefficient. So we will be keeping it over here, minus 3p square q square. Then it is your pq over here literal coefficient, and here literal coefficient is pq. So this plus 7pq, we will keep it over here, one beneath the other. And this is your constant term, plus 5, we will keep it over here. Now we will be adding these two algebraic expression. Over here we can see 2 and minus 3. 2 and minus 3 will be your minus of 1. What we will be doing is, we will be simply working on these, your constants. These constants will be working on the numeral coefficients only. 2 minus 3. If we will be adding these two, 2 and minus 3, we will be getting minus of 1. And p square q square is the literal coefficient. We will keep it as it is. So it will be minus of p square q square. Here your numeral coefficients are your minus 3 and here plus 7. So if we will add minus 3 and plus 7, we will get your 4. And PQ is your literal coefficient. So we will keep it as it is, plus 4 PQ. Plus 4 plus 5, it will be plus of 9. So when we will be adding these two algebraic expression, this is the answer we will be getting. So what we need to do is, we have to keep the literal coefficients whose literal coefficients are same. That means like terms we have to keep one over the other, and then we have to work on the numeral coefficients. We will be adding or subtracting the numeral coefficients, and your literal coefficients will remain same. This p square q square will remain same. 2 minus 3 only we will be checking, and 2 minus 3 is minus 1. So instead of 1, we have simply written minus only. Here minus 3 and plus 7, so it will be 4, because here your literal coefficients are same. So we will keep it as it is, PQ, and these are the constants we have added. So this is how we will be adding the two given algebraic expression. Now if we have to subtract the algebraic expression, then also it could be done on your like terms only. On unlike terms, we cannot add even, we cannot subtract even. That means we cannot combine the terms. If it is your unlike terms are there, then we will take it as it is without doing your combinations. Now what is to be done in this question? Subtract this algebraic expression from this algebraic expression. So from this algebraic expression we have to subtract this. So this will come first. So we will be writing first the algebraic expression over here. 12a minus 9ab plus 5b minus 3, we will be writing this algebraic expression. Now this algebraic expression we will write beneath it, and like terms one over the other. Here it is your 4a, literal coefficient is a, so a here, so we will write 4a here. AB minus 7ab, AB, so we will write minus 7ab here. Then plus 3b, so plus 3b, and then plus 12. Now we have to subtract it, so we will change the sign of this algebraic expression which is to be subtracted. We will change sign of all these terms. So this plus 4a will become minus 4a, this minus 7ab will become plus 7ab, this plus 3b will become minus 3b, and this plus 12 will become minus of 12. Now we will be solving it, or simply we will be adding it. It is your 12a and it is your minus of 4a. Your literal coefficient is same, so what we need to do is simply 12 minus 4 we need to do. 12 minus 4 is 8, so it will be your 8a. It is your minus 9ab and it is your plus 7ab. Minus 9 and plus 7 will be minus of 2, and literal coefficient is your ab. Plus 3b minus 3b, plus 5 and minus 3, plus 5 and minus 3 will be your plus of 2b. Minus of 3 minus of 12, minus 3 minus 12 will be minus of 15. So this will be the answer when we will be subtracting this algebraic expression from this algebraic expression. Subtraction means simply we are adding the additive inverse of it. Like additive inverse of 4a will be your minus of 4a. So if we will be adding minus of 4a in 12a, that simply means we are subtracting your 4a only. Subtraction simply means you're adding your additive inverse, because additive inverse of minus 7ab will be plus 7ab, additive inverse of 3b will be minus of 3b, additive inverse of 12 will be minus of 12. So subtraction simply means you're adding your additive inverse to it. So this is how we can add and subtract any two or more than two given algebraic expressions. If we have to combine the terms, then it is only combined using addition or subtraction if they are your like terms. On unlike terms, we cannot add and subtract. Suppose I am going to take an example. If we have to add 4a plus 7b plus 5, this is one of the algebraic expression. Another algebraic expression is say 3a plus 7. If we have to add these two algebraic expressions, so what we will be doing is, first of all we will write it in column 4a plus 7b plus of 5, and say here one more term is there, say your 2z. These two are the algebraic expression. So we have written first algebraic expression over here. Now it is 3a, so 3a will come beneath your 4a, plus 7 will come here, and it is your 2z. So there is no term whose literal coefficient is your z. So we will be writing 2z here separately. Now we will be adding it. 4 plus 3 will be your 7a. Now there is no literal coefficient of b in this algebraic expression. So we will be writing this 7b as it is. Plus 5 plus 7, it will be plus of 12. And 2z, we will write it as it is. So this is how we will be adding the two given algebraic expression. We will be combining the algebraic expression when they will be having your like terms. If they will be having like terms, then we will be combining it. Otherwise, we will take it as it is. As just now we said that in the case of addition and subtraction of algebraic expression, combination could be done when the terms are your like terms only. But when we are multiplying any algebraic expressions, then there is no such compulsion. We can combine your unlike terms even. Unlike terms could even be combined. Now let's see how we will be multiplying the two given algebraic expressions. See, if suppose your algebraic expression is your 2x and your 3y. If these are the algebraic expression, what we will be doing is, we will be taking your numeral coefficient first. First of all, we will be multiplying the numeral coefficient, like it is your 2 multiplied by 3. It will be your 6, and then we will be multiplying your literal coefficients. Over here it is your x, over here it is your y, so it will be xy. So 6xy will be the product of these two given algebraic expression. In the algebraic expression, what we will be doing is, if your literal coefficient is same, Same, or if x is over here, x is even over here even. So what we will be doing is we will be applying laws of exponents. That simply means if x raised to the power m multiplied by x raised to the power m, we have already studied if the two bases are same and they are having different powers or the same powers even, and there is multiplication sign in between, then powers are going to be added. So it could be written as x raised to the power m plus n. Suppose I am saying it is your x square multiplied by x raised to the power 4. Here we can see bases are same and powers are, this is having power of 2 and this is having power as 4. So what we will be doing is we will be taking x 2 plus your 4, because multiplication sign is there in between, so powers are going to be added. So this could be written as x raised to the power 6. If it is your y raised to the power 5 multiplied by y raised to the power 3, again bases are same and multiplication sign is there in between, so powers are going to be added. So it will be y raised to the power 5 plus 3, that is y raised to the power 8. These laws of exponents we will be using while we will be multiplying two or more than two algebraic expression. Now let's see if we will be multiplying two monomials. Two monomials we are taking. Suppose this is even two monomials only. This is having one term. This is even having one term. The algebraic expressions which are having only one term are known as your monomials. Now see over here. Suppose I am saying 3xy multiplied by your 5x square y. These two are the monomials. So what we will be doing is, first of all, we will be multiplying your numeral coefficients. 3 over here and 5 over here. So 3 multiplied by 5 will be your 15. Now x multiplied by x square. Just now we have seen the laws of exponents. So bases are same. And if bases are same, multiplication sign is there in between. So powers are going to be added. X means x raised to the power 1. So x raised to the power 1 multiplied by x raised to the power 2 will be x raised to the power 1 plus 2. Powers are going to be added. So 1 plus 2 will become 3. X raised to the power 3. Here it is y raised to the power 1. Here it is y raised to the power 1. So y raised to the power 1 multiplied by y raised to the power 1 will become y raised to the power 1 plus 1. That is y raised to the power 2. So if we have taken two monomials, so first of all we will be multiplying the numeral coefficients and then we will be multiplying the literal coefficients. Then we will be combining these two and it will give us the product of any two given monomials. Now if it is more than two monomials are there, suppose I am saying it is your 2, it is one of the monomial, then we are multiplying it by 3xy, then we are multiplying it by your minus of 5, say x square z. Here three monomials are there. This is one of the monomial, this is another monomial, and this is third monomial. So what we will be doing is, first of all we will be multiplying your numeral coefficients. So 2 multiplied by 3 will be 6 and 6 multiplied by minus of 5, it will be your minus of 30. Then we will be taking the literal coefficients. Over here there is no literal coefficient. Here it is your x, here it is your x square. So x multiplied by x square will be, again laws of exponents we will be applying. X raised to the power 1 multiplied by x raised to the power 2 will be x raised to the power 1 plus 2. That is your x raised to the power 3. Here y is there, here there is no y, so we will write y as it is. Here z is there, there is nowhere else z is there, so we will be taking z as it is. So if we'll be multiplying two or more than two monomials, if these three are the monomials, then the product will be your minus 30 x cube yz. See, what we could have done, either this way we could have solved it. Otherwise what we could have done is, we have multiplied this and this. These two monomials we will multiply it first. And then whatsoever the product will come, we will multiply the product with this monomial. We could do in this way even, and directly even all the three monomials we can multiply together. If we will be multiplying these two first. So 2 multiplied by 3 will be your 6xy. Now what you have to do is 6xy multiplied by minus 5x square z. Now if you will be multiplying these two, 6, 5 is 30, minus of 30. X multiplied by x square will be x cube, y and z. The same answer we will be getting. Either in this way you could solve or in this way you could solve it. So if there are more than two monomials, simply first of all multiply all the numeral coefficients and then multiply your literal coefficients. Now, if it is a monomial by binomial, we have to take one as a monomial and we have to multiply monomial by a binomial. Binomial means algebraic expressions with two terms. Like if I am saying it is your 2x multiplied by 3x plus 4y. This is a monomial. We have to multiply this monomial by this binomial. So what we will be doing is we will be applying a distributive law of multiplication over addition. So what, according to it, this could be written as 2x multiplied by 3x. This term will be multiplied by both of these terms. So 2x multiplied by 3x plus sign 2x multiplied by 4y. So this is a distributive law. So what we have done is we have multiplied this monomial by both the two terms. Now if we will be multiplying it, 2 multiplied by 3, again the numeral coefficients will be multiplying first. 2 multiplied by 3 will be your 6, x multiplied by x will be your x square. Plus sign 2 multiplied by 4 will be your 8, x, y, y. So product of these two, one monomial and one binomial, will be your 6x square plus 8xy. Similarly, if I am taking another example, say your 3xy multiplied by 2x square plus say your 5x square y square. If this is a monomial and this is a binomial, again what we will be doing is we will be multiplying this monomial by both the two terms of the binomial. So it could be written as 3xy multiplied by 2x square plus sign 3xy multiplied by 5x square y square. So we will be multiplying, first of all this part we will be solving. 3 multiplied by 2 will be your 6, x multiplied by x square, here x raised to the power 1, here x raised to the power 2, so it will be x raised to the power 1 plus 2, that is x cube. Y we will be writing it. This is the product of these two terms. Now these two terms plus sign, 3 multiplied by 5 will be your 15, x multiplied by x square, x cube, y multiplied by y square, y cube. So this will be the product of these two algebraic expressions. Now let's see if we have to multiply monomial to a trinomial. Trinomial means algebraic expression with three terms. So if this is the case, suppose your monomial is 2x square y square. This is a monomial. We have to multiply this by 3x square y plus say 5x cube y 4 minus of say 4. This is a trinomial. We're having three terms and this is a monomial. If we have to multiply, again we will be applying the law of distribution only. Distribution law will be applying. So we'll be multiplying this monomial by all the three terms of your trinomial. So how we will be writing it? 2x square y square multiplied by 3x square y plus 2x square y square, this term, multiplied by 5x cube y 4, minus sign is there, so we will be writing minus sign here, minus of 2, or we can say first we will write plus here and then inside the bracket we will write minus. Anyhow we can do it. 2x square y square multiplied by minus of 4. This is how we will be multiplying this monomial by a trinomial. We will be multiplying this monomial by all the three terms of the trinomial. So here 2 multiplied by 3 will be 6, x square multiplied by x square will be x raised to the power 4, 2 plus 2 will be 4, y raised to the power 2 multiplied by y, that is y raised to the power 3. First term. Now 2 multiplied by 5 will be 10, x square multiplied by x cube, 2 plus 3 will be your x raised to the power 5. Y raised to the power 2 multiplied by y raised to the power 4, y raised to the power 2 plus 4, powers are going to be added. So 2 plus 4 will become y raised to the power 6. 2 multiplied by minus 4 will be minus of 8 x square y square. So this will be the product of your monomial and your this trinomial. So what we can see over here, if we are going to multiply two monomials, we are getting result is your monomial only. Two monomials, if we are going to multiply, your result will be a monomial only. That means in the product also you will be getting only one term. If you will be multiplying more than 2, it could be 3, it could be 4 monomials together, then also your result will be a monomial only. If you will be multiplying 2, 3, 4 monomials together, your result will be a monomial. That means you will be getting only one term as a product. Here, if you have multiplied a monomial by a binomial, your result will be a binomial. If you will be multiplying a monomial by a trinomial, your result will be a trinomial. So this is, you can conclude from all this what we have done till now. Now let's see how to multiply a binomial by a binomial only. See over here, there are two binomials are there. One is your x plus 7y, another is your 7x minus y. We have to multiply these two binomials. Binomials means algebraic expressions with two terms. So in both the two algebraic expressions, there are two terms are there. If we have to multiply these two algebraic expressions, then how we will be multiplying it? So what we will be doing is, we will be taking all the terms, means this term separately, this term separately. We will be multiplying this x by both the two terms of another algebraic expression. Then we will be taking your 7y, and then we will be multiplying this 7y by your both the two terms of your algebraic expression. So how we will be writing it? First of all, this x will be multiplied by your 7x minus y. This x will be multiplied by both of them. Then we will be taking your plus of 7y, and this plus of 7y will be multiplied by both of them, that is 7x minus y. Now again we will be applying your distributive law only. This x will be multiplied by both the two terms. This 7y will be multiplied by both the two terms. So it will be x multiplied by your 7x, then x multiplied by your minus of y. These two we have taken. Now we will be taking plus of 7y multiplied by your 7 of x. This 7y will be multiplied by your minus of y. So we have taken, first of all, we have taken x. We have multiplied this x by your both the two terms, that is 7x minus y. Then we have taken plus of 7y, and we have multiplied this plus of 7y by both of them, that is your 7x minus y. So what we have done is x multiplied by 7x plus x multiplied by minus of y plus 7y multiplied by 7x plus 7y multiplied by your minus y. Now what will come? X multiplied by 7x. X multiplied by 7x will be your numeral coefficient will be 7. X multiplied by x will be your x square. X multiplied by minus y will be minus of x y. 7 multiplied by 7 will be your 49. X multiplied by y will be your x y. Now here plus multiplied by minus will be your minus. Numeral coefficient will be 7, and y multiplied by y will be your y square. Over here we can see that this minus of xy and this 49xy, they are having your same literal coefficient, that is your xy. So we can combine these two numbers, these two minus xy and plus 49xy, these two terms can be combined because they are your like terms. So we will be writing 7x square minus of xy plus of 49xy will be plus of 48xy. Minus of xy means minus of 1 times of xy, minus 1 plus 49 will be plus of 48 plus of 48xy minus 7y square. So this will be the answer when we will be multiplying these two binomials. Now let's see when a binomial is multiplied by a trinomial. What we will be doing, the same procedure we will be following. First of all, 3x will be multiplied by all three terms of this polynomial, this your algebraic expression, and then this 2y will be multiplied by all the three terms of this algebraic expression. So first of all, we will be writing 3x multiplied by 2x square plus 3y square plus 5. Then we will be taking the second term, that is plus of 2y. It is going to multiply by 2x square plus 3y square plus of 5. Now this 3x will be multiplied by all three terms. This 2y will be multiplied by all three terms. Now 3x multiplied by 2x square. These two are going to multiply, plus 3x is going to multiply by your 3y square, plus 3x is going to multiply by 5. First part solved. Then 2y will be multiplied by this 2x square plus 2y will be multiplied by 3y square, then plus 2y will be multiplied by your 5. Now we'll be multiplying it. 3 multiplied by 2 will be your 6. X multiplied by x square will be x raised to the power 1 plus 2, that is 3. Here 3 multiplied by 3. First of all, numeral coefficients will be multiplying. 3 multiplied by 3 will be 9. X, and it is your y square. 5 3s are 15, so it will be 15x. Product of these two, 2 multiplied by 2 will be your 4. It is your x square, and it is your y. Here 2 multiplied by 3 will be your 6. Y multiplied by y square will be your y cube. Plus 5 2s are 10 y. Now just check it out whether there is any like term is there. If any like term is there, then we can combine these two like terms. X cube, there is no other term of with x cube. X y square, it is your x square y. So they are even unlike terms. This is having x, this is having y, this is y cube. So all the terms are your unlike terms. So this will be your answer. So this is how we can multiply any given algebraic expression by another algebraic expression. Now coming to division. As in the case of multiplication, we have applied laws of exponents. Similarly for division also, we will be applying laws of exponent. If it is x raised to the power m divided by x raised to the power n, that means bases are same and division sign is there in between, then we will be subtracting the powers. This is the case when m is greater than your n. In that case, we will be writing it as x raised to the power m minus n. So this is how we will be solving it. Whatsoever the variables will be there and division sign will be there in between. So using this law of exponents, we will be solving the questions. Now how to divide a monomial by a monomial only. Suppose we have to divide, say 15 x cube y square divided by your 5 x square y. If we have to divide these two, what we will be doing is, we can write it like this even, 15x cube y square divided by your 5x square y. Now 15 divided by 5 will be, first of all, numeral coefficients will be dividing. It will be your 3. 5 3s are 15. Now here x cube and here x square. Bases are same, x cube and x square, and division sign is there in between. So powers are going to be subtracted. So it will be 3 minus 2, x raised to the power 3 minus 2 it will be. So it will be x. Because x raised to the power 3 minus 2. What we can write it as, x raised to the power 3 divided by x raised to the power 2. This is the part. So this could be written as x raised to the power 3 minus 2. That is x raised to the power 1, or we can say x. Here y square divided by y. Again, it is y square divided by y. Bases are same. Powers are going to be subtracted. So it will be y raised to the power 2 minus 1. That is y. So this will be the answer. This is how we can divide a monomial by a monomial. Now let's see how to divide a polynomial by a monomial. So here we have taken this polynomial which is having 3 terms, and we have to divide this polynomial by your monomial which is having your 1 term only. Now how will be dividing it? Individually each term of this polynomial will be divided by your monomial. So how we will be writing it? It will be written as 12x cube y raised to the power 4 divided by 3x square y square minus of 6x raised to the power 4 y raised to the power 5 divided by 3x square y square plus 3x square y cube divided by 3x square y square. Now again laws of exponents will be applying. First of all, numeral coefficients will be dividing. 12 divided by 3 will be your 4. Now x raised to the power 3 divided by x raised to the power 2. So powers are going to be subtracted, bases are same. So x raised to the power 3 minus 2, that is x raised to the power 1, or we can write x only. Y raised to the power 4 divided by y raised to the power 2. So y raised to the power 4 minus 2, that is y raised to the power 2. Minus 6 divided by 3 will be your 2. 3 2s are 6, so it will be 2. Now x raised to the power 4 and here x raised to the power 2. So bases are same, powers will be subtracted. X raised to the power 4 minus 2, that is x square. Y raised to the power 5 divided by y raised to the power 2. Again bases are same, so powers will be subtracted. Y raised to the power 5 minus 3, that is 5 minus 2, that is y raised to the power 3. Here 3 and 3 both are going to cancel. X square are going to cancel. So it will be y raised to the power 3 divided by y raised to the power 2. So y raised to the power 3 minus 2, that is y only. So this is how we can divide a polynomial by a monomial also. Now let's see how to simplify your algebraic expression. So we know the law, that is your first of all your brackets are solved. What the law is there? BODMAS, we know that. First of all bracket we are solving. First of all brackets are solved. Then it is your off. Off means your multiplication only. Then your division. It is for D for division. M for multiplication. Then comes your addition. And then your S for subtraction. So this is the order which we will be following when all these operations are given all together. In any of the expression, your plus is even there, minus is even there, multiplication, division, brackets, if all these are given or few of these are given, then in this order we will be solving it. In the bracket, even first of all vinculum are solved. First of all your vinculum or your bar bracket is solved first of all. Then it is your small bracket or the parenthesis. Then your curly bracket or your middle bracket we can say. And then your square bracket or your big bracket is solved. So this is the order in which we are solving any of the algebraic expression given to us. Suppose it is given that 5 plus xy plus your say 2 in the bracket, it is your 3x plus y minus of say xy plus 3, like this. This is the bracket closed. If this is like given to us, then how we will be simplifying it? It is your 5 plus xy. First of all vinculum will be solved. So we'll be writing rest all the things as it is. 3 multiplied by x plus y. This minus will be multiplied by both of them. So it will become minus of xy and minus of 3. Now 5 plus xy plus 2. This 3 will be multiplied by all these terms. So 3 multiplied by x will be your 3x. 3 multiplied by y will be your 3y. 3 multiplied by minus xy will be minus of 3xy. 3 multiplied by minus 3 will be minus of 9. Now we will be multiplying this 2 by all these terms. Now it will be 5 plus xy plus 2 multiplied by 3x will be 6x. 2 multiplied by 3y will be your 6y. 2 multiplied by minus of 3xy minus of 6xy, and 2 multiplied by minus 9 will be minus of 18. Now see the like terms. This term xy and this minus 6xy are like terms, and this 5 and this minus 18 is the like terms. So we will solve it further. 5 minus 18. 5 minus 18 will be minus of 13. Xy minus of 6y. Here 1xy, here minus of 6xy. So 1 minus 6 will be minus of 5xy plus 6x plus 6y will be the answer. So whenever it is like this, in which your multiplication, division or your brackets all are combinedly given, in that case first of all brackets are solved. In the brackets even first of all vinculum, then small bracket, then middle bracket, then big brackets are solved. After that we will be doing your off, that is your multiplication, then your division, multiplication, addition and your subtraction. This is the order which we will be following. Now let's solve some of the questions based on whatsoever we have learned till now. Product of these three monomials we have to do. So what we will be doing is, first of all we'll be multiplying the numeral coefficients. 2 multiplied by 4 will be 8, and 8 multiplied by 8 will be 8 is 64. So it will be your 64. Here it is y and here it is your y square. So y multiplied by y square will be, bases are same, powers are going to be added. So y raised to the power 1 plus 2, that is y raised to the power 3. This will be the product of these three monomials. Now if we have to multiply these two, so what we will be doing is, first of all we'll be multiplying your numeral coefficients, that is your minus of 10 by 3 multiplied by your 6 by 5. So 5 2s are 10, 3 2s are 6. So minus 2 multiplied by 2, it will be your minus of 4. Now p multiplied by pq will be p raised to the power 1 plus 3, that is p raised to the power 4. Then q raised to the power 3 multiplied by q, that will be q raised to the power 3 plus 1, that is q raised to the power 4. This will be the product of these two monomials. Now, if we have to solve this at x is equivalent to 3, so what we will be doing is, first of all, we will be solving this part. This is your 3x, 4x minus 5 plus 3. Then wheresoever x will be coming, we will be keeping x is equivalent to 3. So first of all, let's solve it. 3x will be multiplied by both the two terms, that is 3x multiplied by 4x plus 3x multiplied by your minus of 5 plus of 3. So 3, 4 is 12. X multiplied by x will be your x square. 3 multiplied by minus 5 will be minus of 15x. And it is your plus of 3. This is the solution for this part. Now we have to keep x is equivalent to 3. So at x is equivalent to 3, it will be 12 multiplied by, instead of x we have kept 3, minus of 15, instead of x we have taken 3 plus 3. 3 3s are 9 and 12 9 is 108 minus 15 3s are 45 plus of 3. So we will be solving it further. 8 minus 5 is your 3 and 10 minus 6 is 4 is your 6 plus 3, that is your 66 will be the answer. We will be keeping x is equivalent to 3. Your result will be your 66. Now if we have to solve this part, so again first of all vinculum will be solved as just now we discussed. So rest all the things we will be writing as it is. X minus y minus of x plus y, minus will be multiplied by both of them, minus of x, and this will become plus of y. Now a small bracket will be solved. X minus y, this minus will be multiplied by both of them. So minus of x, minus of y, minus of x, plus of y. See over here, x and minus x cancelled, your plus y and minus y cancelled. So it is your x minus y minus of, this is your minus y remaining, and here it is your minus of x remaining. Now x minus y, this minus will be multiplied by both of them, so sign are going to change. Minus multiplied by minus y will be your plus of y, minus multiplied by minus x will be your plus of x. Plus y minus y cancelled, x plus x will be your 2x. So this is how we can simplify it. So this is all from this chapter. Hope it is clear to you what algebraic expression is, what all are the types of algebraic expression, and how we can multiply, divide, plus and minus your algebraic expression. Soon we'll be coming with the more videos of class 8 maths curriculum. If you are having any doubts related to it, you can comment me. I'll try to respond at my earliest. Thank you.